In this video, we're going to be looking at solving linear equations. And when it comes to solving equations, there really isn't any limit to how complex or difficult things can get. But fortunately for us, linear equations are probably the simplest types of equations out there. So first off, I'm going to try to clarify for you just what exactly a variable is, because you're going to be exposed to that term quite a bit. Now, a variable is any letter that represents a number. And the reason we use variables when in place of numbers is because we don't know what that particular number is. Essentially, a variable is like a blank, and an equation is like a problem where we have to fill in a blank. So it's like if you had a situation of 5 plus blank equals 10, well, you'd be looking at what goes in this blank to get 5 plus something equals 10. Well, in math, we don't use blanks, we use variables. So rather than writing it like that, we would write it as 5 plus x equals 10. And it really doesn't matter what letter you use. It could be A, B, C, whatever you choose. But typically in algebra, you'll see the letter x. So that's what a variable is. And you have to figure out what this variable is going to be to make this situation equal to 10. So in this particular instance, x is going to equal 5 because 5 plus 5 equals 10. So x equals 5. And that would be how you solve for x in this particular instance. So now we're going to look at how you go about solving for variables in equations. So to start off with, I'll give you something almost identical to what I just gave you. X plus 10 equals 20. Now, what does this mean? We can probably see by now that it's what number plus 10 equals 20. So with solving equations, you're essentially looking for opposites. And what I mean by that is when you have something like x plus something, you're going to try to do the opposite of that. So you're going to do x minus something. So obviously the opposite of addition is going to be subtraction, and the opposite of multiplication is going to be division. And in this instance, we have x plus 10 equals 20. So to get rid of this addition, we're going to do subtraction. So we're going to do x, and up here we're going to go minus 10. And so that will get rid of the 10 on this side of the equation. And in any type of equation, what you do to one side, you always have to do to the other side. So you're going to have to subtract 10 from the other side as well. So you'll have x equal to 20 minus 10, which equals 10. So x equals 10. And what's really nice about algebra is you can always go back and check your answer. So if x equals 10, then the situation x plus 10 equals 20 can be checked simply by plugging this 10 back in up here. So let's do that now. So 10 plus 10 equals 20. And 10 plus 10 does in fact equal 20, so this situation is true. So now we're going to be, I'll try to make it a little bit more complicated so you can be exposed to different types of situations. So to start off with on this one, let's go with an example of multiplication now. So let's say you have 3x equals 15. Now, anytime you see a variable next to what we call a coefficient, which is this big 3 here next to the x, it's the same as 3 times the variable. So 3x is 3 times x. So 3 times x equals 15. Now, like I said before, the opposite of multiplication is division. So to get this x by itself, we're going to divide by 3. Because in algebra, that's what you're trying to do always. You're trying to get x by itself. So 3x divided by 3, 3 over 3 is 1, and 1 times x is the same as x. So these 3's cancel out. But again, what we do to one side, we have to do to the other side also. So we have 15 over 3. So now we bring our x down, and 15 divided by 3 equals 5. So that's going to be what x equals. Now again, let's check our answer by plugging this x back into the original equation. So 3x equals 15. Let's check this by plugging 5 in for 3. So 3 times 5 equals 15. 3 times 5 does in fact equal 15, so we know that this is correct. So now let's go with a combination of addition and subtraction. Let's do something like 4x plus 10 equals 30. So now we have an instance of multiplication and addition in this equation. And so to start off with, to get our x by itself, we are going to subtract 10 from both sides because we have addition and the opposite is subtraction. So minus 10 and minus 10 on each side. So 4x equals 30 minus 10, which equals 20. So now we're left with multiplication. And as we know, the opposite of multiplication is division. So 4 times x, the opposite of that is going to be divided by 4. So 4 over 4 is 1, and 1 times x is just x. And we have to do that to this side as well. So x equals 20 divided by 4, which is 5. Now, once again, let's plug that back into our original and prove that it's correct. So 4 times 5 plus 10 equals 30. Well, what's 4 times 5? It's 20. And 20 plus, sorry about that, 20 plus 10 does in fact equal 30. So we know that that situation is accurate as well. So now let's keep going with this and get a little bit more complicated. So let's go with something like, I'll give you a couple more examples here. So let's go 2 times x plus 7 equals 20. So now this is why the distributive property was important to learn, because now we're going to end up using it to solve equations. So we're going to distribute this 2 through this whole thing and end up with 2x plus 14 equals 20. So now, again, let's subtract the 14 from each side. Get 2x equal to 6. And now we just have multiplication, and the opposite of multiplication is division. So divided by 2, x equals 3. Now, just for the sake of sanity, let's plug this in and prove that it works. So now, 2 times our 3 for x plus 7 equals 20. Okay, so 3 plus 7 is 10, so we have 2 times 10 equals 20. 2 times 10 is in fact 20, so we know that it works yet again. So now, I'll give you one more example. Let's do something like, something with a fraction. So x over 5 times 4 plus 2 minus 7 equals negative 4. Okay, so now don't get too intimidated by this just because there's a fraction and distributive property and so many different things going on. Let's just take it one step at a time and it won't be too bad. So first off, what I would do is add the 7 to both sides, just to simplify things up a little bit. So let's go plus 7 on both sides, and we'll get x over 5 times 4 plus 2 equals 3. So now, oh sorry about that. So now we have this situation here, and we can simplify the things in the parentheses. Obviously 4 plus 2 equals 6, so we might as well do that rather than distributing this fraction through, because that would be pretty complicated. So we have x over 5 times 6 equals 3. So now 6 is the same as 6 over 1, so we can write it as that, which will make this multiplication move here a little bit simpler to see. So x over 5 times 6 over 1 is going to leave us with 6x over 5 equal to 3. So now we have division and multiplication. So first off, let's multiply by 5 on each side to get rid of this 5 here. So multiply by 5 over 1 and multiply by 5 over 1 here. Now that's going to give us an answer here of, these 5's are going to cancel, leaving us with 6x equal to 3 over 1 times 5 over 1, which is equal to 15. So now we have 6x equal to 15. All we have to do is do the opposite of our multiplication here, which is division. Divide by 6. Those 6's will cancel. And then divide by 6 on this side as well. And our answer will be x equals 15 over 6. Or if you wanted it as a mixed number, you could say x equals 2 and 1/2 if you wanted. So that's how you do linear equations, and things can get a little bit more complicated in the future, but thus far these should be pretty simple to work out if you understand what you're doing.